Hi, I'm Justine here on the Browser Based podcast at AIE. I'm super lucky today to be joined by Stefania, who works at Sakana, a frontier research lab in Japan. Stefania actually flew in on Sunday, is that right?
I did, yeah. I'm still a bit jet lagged, but I'm hanging in there.
Well,
Yes.
welcome to San
Thank
Francisco.
you. It's my old stomping ground, so it's always good to come back.
Amazing. Can you tell us a little bit about, what brings you to AIE? What are you speaking about this week?
This week I'm going to talk about local harnesses for long horizon tasks, and in particular I'm going to focus on harnesses that optimize for memory. So when you're running auto research on tasks that can run for, I don't know, a day, 2 days, for a very long time, what happens is that you get catastrophic forgetting and contexts like collapse. So we need to have like more solutions for how to handle memory in that case.
Mhm.
And just a simple thing like file like retrieval is already helping. But what I'm going to show is like a little bit more advanced solutions that help in that context. And I love coming to AIE because it's always for me fun to prepare like the talk and do a demo. And I like to work on side projects that are really pushing like my knowledge and also are kind of top of mind for people. So I decided to work on this 3 weeks ago. And one of the reasons for that was Fable got blocked, right? So it's a lot of people got much more excited about open source models and local models. So I wanted to see how far I can get with some of the most difficult tasks that we're currently running with local models. Like DeepSeek V4 Flash can now run on a Mac Studio, which is pretty amazing. So yeah, that's going to be the talk on Wednesday.
Super interesting. And I think it's very fascinating that you're representing also like an international research lab flying all the way from Japan. I know you previously have research at like DeepMind, and if you worked at MIT as well. I'm curious if you can talk about, more generally, what's it like doing research outside of the United States and, being in Japan?
It's a lot of fun. So first, maybe I'll explain why we're called Sakana. So Sakana means fish in Japanese. And the company is very much inspired by nature, collective intelligence, open-endedness. So it was named Fish because we were very inspired by the school of fish and how they self-organize and how you can use that as a model of different forms of intelligence and maybe more emergent forms of exploration. That's the story behind Sakana. And we recently launched a router model called Fugu. So it's our first like public model. You can play with it.
Yeah.
And the performance is really good. But the vision for that router and the company in general is very much focused on sovereign AI. So the router model allows you to plug in any models you want to use, proprietary or open source or local. And depending on your tasks, decides which model is best for the question you're asking. And that allows anyone to not be reliant on a single provider. So it really allows like to have this more sovereign approach. We also released Sakana Chat. So it actually works with local dialects, Osaka dialects, and it's much more like aware of, in Japanese, you have a formal way of speaking. It's called keigo, and informal. So supporting like the different registers of politeness. The speech, we're working on a speech model, which is going to be much better for Japanese. A deep research agent called Marlin, which is using a technology we pioneered on model merging. So there's a lot coming out of the lab,
Wow.
and we're having a lot of fun. And I'm very happy that a lot of the research is open source. So we're very much contributing and investing in the ecosystem as well.
Love the focus on sovereign AI. I think especially like you mentioned, like with Fable being blocked and all these international concerns that we have now, like learning how agents can adapt to like human use cases, like real like education and policy and all of these like very like societal concerns are like very, very valid today.
Yeah, it's a topic that is very close to my heart because I worked a lot on AI education. I actually started working on AI education back in 2015 when I was at MIT as part of Scratch team, which is the most popular coding platform for youth. And I realized how important it is like to democratize access to computational thinking, to AI literacy. And the best way of doing that is by allowing young people to build their own models and then to use those models in their games or in their programs. And more recently, I actually built a copilot for young people as well. It's open source, it's in Scratch, so but it's Socratic, so it doesn't do the code for you. Like it just asks you questions. So when you get stuck and you don't know how to program, like you can get unstuck or get ideas. But it's been nice to test that with youth all over the world. Like I tested it with youth in 15 different countries, and it works in a lot of major languages. And I think that's been very eye-opening because I think when we are in North America or here in Silicon Valley, we think everyone is AGI built and like AI native, but internationally that's not the case.
No.
So not leaving people behind and also kind of meeting like each culture and each country, like where they're at in terms of what they care about and what they need and how they want to approach integrating technology in their lives on their own terms.
Yeah, I think it's interesting that your work kind of covered this tension of like, what are like the everyday human non-AGI pilled use cases? How do we get them ahead? But also at the same time, you're working on like long research and like self-improving agents at the very frontier.
Yeah.
Like, how do you kind of balance the shift between like open source, like models for everyone, but also like pushing the frontier at the same time?
It's a good question. My North Star has always been aligning with people on values because I think if we align on values, then as a community, we can answer hard questions. So I don't think I have all the answers. I don't think any single individual has all the answers. And we sometimes tend to put people on a pedestal when in actuality, going back to the school of fish, right? Like it's much better when we try to figure out hard problems together in specific contexts, right? So I trust our team and all of our partners and collaborators in the ecosystem to figure out what does a meaningful version of RSI looks like in Japan. Like what sort of recursive self-improvement systems we want to have there and how do we draw the line, right? Or how do we make sure they're safe and verifiable and useful? But yeah, in order to do that, there needs to be trust and there needs to be a value alignment.
Yeah. And in addition to that value alignment too, it's like I think our company we work on browser use. And so, how do we get agents to use the browser in a way that a human would? A big part of our work is like evaluating with human judgment all these non-deterministic tasks.
Yeah.
Of, if a human were to fill out this healthcare form, how does the agent do it compared to the human? Like evaluations is a topic that we think a lot about, especially in this transition
Yeah.
to these self-improving agents. How does Sakana and how does your research approach evaluations?
We do a lot of evals,
Yeah.
of course. Everyone does. And we also do human studies with consumers and with users.
Yeah.
And I think the direction in which the industry is going is towards continuous evaluation. So, and not so much benchmark maxing, right? Or eval maxing, which I'm very excited about.
Yeah.
I understand why we had these benchmarks to get to where we are today in terms of capabilities. But right now, we need to approach the problem much more holistically. So maybe you could have very good performance, but people care more about latency in certain situations, right?
Yeah.
Or maybe you have very good performance and latency, but your UI sucks. So understanding like what you're optimizing for in context, I think is very important.
I know that you've done work on like human computer interaction as well.
Yeah.
Curious of like you've done research in like the current frontier of like computer use. Like what are your thoughts on the future of computer use?
So I didn't study computer use per se, but I am testing a lot of AI applications and systems with people. And I use computer use myself to all the time. I'm trying to figure out how to make it useful, which is hard.
Yeah.
But I think the reason it's hard, and I saw this question recently on Twitter, I think someone was asking, is like, why is computer use still so bad, right? Like the models have increased in capabilities so much in reasoning and multimodality. Why is computer use so hard? And I think it is because with coding, it was easier to give it feedback or let it run in the background or just correct like a few edits. Like it wasn't as much of a headache for developers to give feedback. In computer use, it's sometimes too much of a headache to give feedback or assist it because it's too slow, or it's like breaks in ways that you don't expect, right? So it's not intuitive, like where you need to help it or not need to help it. And a big unlock for me for computer use has been to use agents, right? Like could be a Pi, which is open source,
Yeah.
or it could be Codex or any of the right like existing harnesses. But then figure out how to prepare the context, like do the context engineering. So I'll give you a specific example. I hate doing paperwork and I hate like filling reimbursements or
Yeah.
insurance claims, right? So now I got into a habit of taking pictures and then putting all those pictures in a specific album and have a prompt template that I'm going to use and say, open my browser, go through each pictures, and then go to this URL, like, and put it in a spreadsheet. So I'm not asking the agent to actually fill in the forms for me, but I'm asking the agent to prepare the information so I can fill the form very fast. Because I figured that when the agent was trying to click the buttons and go like line by line and filling the forms was too slow. But
Mm.
now I figured out how to use it such that it can accelerate my work. And that's a stepping stone to get the agents to get better and eventually do it themselves, right? But like closing that loop of how do we make it useful enough for people so they have the patience to give feedback to the system? That's I think that's the tricky part in computer use. It needs to be useful enough, right?
Yeah, and then like we're just starting to hit that threshold of like,
Yes.
okay, like people don't get too annoyed. Like the
Right.
agent kind of knows what they want.
Yeah.
And like enough that we have volume of evaluation, I guess is what you're saying, right?
Yeah, and I think starting with queries where it's not consequential, right? Like it doesn't need to handle financial transaction. Like we're not
Yeah.
going to start with the most complicated, most risky scenarios,
Yeah.
but maybe low friction and high throughput. Yeah.
Mhm. And going back to kind of what you're talking about this week in terms of like long form research agents and like
Mm-hmm.
self like learning agents,
Yep.
what do you think are like the few use cases in which like that's the most important right now that you're focusing on that you think that these frontier models need to be working and in production for?
Yeah. So I think a lot of prior auto research was very much, or just research,
Yeah.
focused on problem spaces where it's high impact, but we also have a lot of data, right? So let's say we want to do targeted treatment for a type of condition, right? You would need to have enough data from people in order to figure out patterns or analyze the X-rays. But with auto research now, I think even for very narrow cases where maybe it's a rare condition, or it's a very rare problem, you being able to run that long horizon auto research pipeline allows you to target like one-off hard problems.
Yeah.
It lowers the barrier of entry for those type of situation, and the impact is obviously quite meaningful. Other examples are like you can think of this as a Venn diagram where you have a lot of problems, and maybe there's a lot of data that is parsable for machines, but not so parsable for humans, and very few researchers. So one example for that is math. So that's why we saw the Erdos conjecture that was disproved by OpenAI is because there's just so many open questions in mathematics, not so many, like the community of mathematicians is actually quite small.
Yeah.
And it's verifiable, right? So we have a way of providing feedback to the auto research agents, like
Mhm.
when they got the answer right or wrong, or verifying if what they did is correct. So that makes it fertile ground for this type of workflows. Other examples like that are in, I don't know, genomics, like domains where we have
Yeah.
infinite amount of data, limited amount of human research power, and a lot of open questions. So
So more like deterministic like research
and
fields
and and,
that
and
are
definitely verification is one of the bottlenecks. Yeah.
right,
It's
for
like, how
sure.
do we know it's true? Like, do we actually test it in the lab? Like, if we're gonna get like a new material, like, are we gonna try to create it in the lab
Yeah.
and see if it works, right? Or a new drug, or so. Yeah, the verification is very important.
And also like the speed of the verification too. It's like if
Exactly.
you run that like chemical experiment, what if it takes like a year,
And then you're
to
like,
show
oh
it?
yes, yeah,
Yeah. So math, science, genomics, like
yeah.
kind of like right away
And then
response.
in medicine, like very unique, like narrowed, long tail
Yeah.
scenarios.
Like I'm
Yeah.
like a history researcher, right? And so that's
Mm,
super like subjective kind of work in terms of like writing. And I think that like a lot of your success is based on like more of human judgment rather than
that's
things.
hard.
Yeah, this is like a
Yeah.
whole nother.
I don't think we need auto research in all of
No.
domains, right? Like, so in history, they recently like decoded the scrolls, the Herculaneum scrolls. Like, there were some scrolls that were
Well,
burned in the Vesuvius eruption, and trying to decipher them meant like destroying the scroll. So they had to be certain that when they're like unrolling them, they can decode what's written because there was no going back. And they recently managed to decode the entire Herculean like
Wow.
scroll after many years.
Yeah.
So that's maybe a history example where you would really
Cool.
need auto research.
Yeah.
But like if it comes to interpretation or writing or
Yeah. Maybe some things are left human. Maybe
Yes.
something should be left
I
human.
think a lot of things should be left
Yeah.
human.
For
Yeah.
sure.
What are we gonna do? Like if we automate everything, like
It's always just to make, human advancement less tedious and, faster for the things that really, really matter. But
exactly.
for sure agree. Some things are better left human.
Yeah, and I think like this human in the loop kind of puts too much of the focus on the technology. It's not about the human in the loop. No, it's like human at the center.
Human in the center.
Yeah.
And I think that your work in sovereign AI, and also like giving the human the power to pick what open source model they want to use is like very central to this question.
Yep.
So I'm excited to hear your talk and
Thank you.
to learn more about your work. Thanks so much for sharing.
Thanks for having me.